Today, let's understand unconditional coverage, also called the Kupiec test, in the simplest way possible. Imagine your VAR model says you have a 95% confidence level. What are you really claiming? You're basically saying, hey, losses should exceed my VAR only 5% of the time. So out of 100 days, you expect about 5 bad days. Out of 250 trading days, maybe around 12 or 13 failures. Now, the big question is, did your model actually fail only that many times, or did it mess up more often? That's exactly what unconditional coverage checks. It doesn't care when the failures happen or whether they come together or separately. It only cares about the total count. Think of it like counting total absences in a class. You don't care which days students were absent, just how many times they missed school. To run this test, we only need 3 simple inputs. P, which is the probability of failure like 5% or 1%, T, which is the number of days we observed, and N, which is the number of exceptions where losses actually crossed VAR. First, we calculate expected failures using T times P. Then we compare this expected number with the actual number N. If these two numbers are close, the model is doing fine. If they're very different, something is wrong with the model. Statistically, we calculate something called the likelihood ratio statistic, or LRUC, and it follows a chi-square distribution with 1 degree of freedom. At the 95% confidence level, the magic number to remember is 3.84. If LRUC is greater than 3.84, we reject the model. If it's less than or equal to 3.84, we accept it. In exams, you usually just compare with this number and move on. Now let's build some intuition. Suppose your VAR says 5% failures, but you actually see 25% failures. That means your model underestimated risk, which is dangerous because you weren't prepared for losses. On the other hand, if you see almost 0 failures, the model is too conservative, which means you're holding too much capital and reducing profits. Both situations mean the model isn't accurate. A simple real-life example is a weather app that says only 5% chance of rain. In 100 days, it should rain about 5 days. But if it rains 25 days or never rains at all, you'd stop trusting that app. VAR backtesting works exactly the same way. We're checking whether predictions match reality. One more thing that's super important is sample size. If you only test for a small number of days, randomness can fool you and even a bad model might look fine. But as you increase the number of observations, like 1,000 days, the test becomes stricter and more reliable. More data means we can detect mistakes more easily. That's why larger samples give stronger conclusions. The good part about the Kupiec test is that it's very simple, quick to compute, and widely used by regulators like Basel. You only need the count of exceptions. Nothing complicated. But the limitation is that it ignores timing. 10 losses happening consecutively or spread across the year look exactly the same to this test, even though clustering clearly shows higher risk. So it cannot detect volatility changes or patterns in losses. For that, we need more advanced tests like conditional coverage.